Okay, this is MAT 175, Lesson 5, Section 3.2, Linear Models, Building Linear Functions from Data. First thing we're going to look at are drawing and interpreting scatter plot diagrams. Okay, here we have a table of temperatures versus relative humidity. And we put the relative humidity on the x. We're going to put that on the x-axis, and the temperature that's going to go on the y-axis. And notice you have here relative humidity 0, temperature 64, and so we're going to look at that as a coordinate point at 0, 64. Relative humidity of 10 is recorded at temperature of 65, and so that would be 10, 65, and so on. And what we're going to do is we're going to draw a scatter plot diagram by hand, treating relative humidity as the independent variable. In other words, the x. And the apparent temperature, that's going to be the dependent variable. That'll be our y. And we're going to use a graphing utility to draw the scatter plot, or also known as a scatter diagram. Describe what happens to the apparent temperature as the relative humidity increases. Alright, we're going to see a relationship here between relative humidity and temperature. And so here's a scatter plot that was drawn out on, you could say, like a piece of paper. And so if you look here, this is 0, 64 as a coordinate point. There it is. There's 0 and 64 degrees. And here's 10, 65, and so this is 10, a relative humidity of 10%, and there's 65 in between 64 and 66, and so on. And so this is what it looks like on the graphing calculator. And I will show you how to get this in a few minutes. Get that scatter plot on the TI-83 or 84. We use the 84, but the process is the same for the TI-83. So you can see that as relative humidity increases, also temperature increases as well. Well, you know, really, as temperature increases, relative humidity increases. So there's a positive relationship here. Okay, we want to distinguish between linear and nonlinear relations or graphs. Here we have a relatively straight, fairly linear relationship here. Positive, going in positive or positive slope, and then here our positive correlation. Here this is a negative correlation with a negative slope, where m is less than 0. Here this is more parabolic, it's not linear. And here this is more cubic or x cubed. It's more x cubed shaped, and that's also nonlinear. And here this is more of a exponential growth, and that's also nonlinear. It kind of looks linear. If linear would come out more like, straight out like that, but this curves up, so that can't be linear. Okay, we want to determine the relationships between linear and nonlinear. So we look at this graph here, and we can see that that's linear. So looking at graph B, can you tell if that's linear or nonlinear? You should state that this is a nonlinear graph. Okay, graph C, linear or nonlinear? Again, nonlinear. And graph D, that is also nonlinear because it curves up. Again, linear would be going straight out that way. Okay, so we want to find a model, a mathematical equation or a mathematical model with a linearly related data. And so we look at 2 points. Usually you want to look at a point that's in the beginning of the table and a point that's at the end. You don't want anything that's too close, because then you really don't get a very good relationship that way. So here this graph here shows 10, 65 as one point and 80, 74 for another point. And what we do here is we put in the slope of 2 points. We use the slope of 2 points equation. So the 10, 65, that's furthest to the left, and that's going to be our x1, y1. 80, 74, that's our x2, y2. So y2 is 74 minus y1 is 65 over x2 is 80 minus x1 is 10. And we get 9 over 70. Okay, what do you think we would do now to get our equation? Well, we would use the point slope equation. And we would go ahead and use the first point is our x1, y1, and here's our slope. So we put in here 65 for y1. There's our slope, 9 over 70 minus x minus times x minus 10, our x1. And so we go ahead and simplify that to get our y equals mx plus b equation, and we get, so basically they took the 70, multiplied it to both sides, 70's canceled, multiplied 70 here, and then simplified. And they got 9 over 70x plus 446 over 7. Okay, so that's our model. Alright, so now what we want to do is this is called the line of best fit here. This equation fit into that model there. And you can see that the model is pretty close, not exact, but it's pretty close. Here's our 2 points that we used, 10, 65, and the other one was here at 70, 70, 80, I believe it was. But anyways, these are the 2 points that we use. That's why the line goes through those 2 points. Okay, using graphing calculator for line of best fit. Alright, what we do is we take the calculator. Alright, now before we get to this point here, I'm going to show you some things on how to, first you want to clear your calculator of any data. So we're going to come out of this PowerPoint notes and let's take a look at our graphing calculator. Alright, now what you want to do is you want to see if there are any data in your, what we call your lists. So we're going to go to Stat and then Edit, and we see there's data in there. We don't want that. We want to clear that first. So so what we're going to do is we go to Second and Memory. And so memory is the second feature, and then the plus sign, memory is above that. Okay, we go to 4, clear all lists. So you can either cursor down or just hit 4. And there's clear all lists, and then we're going to hit enter. And it marks done. So it's cleared the list for us. Well, let's take a look. We go to Stat and Edit, and there we go. Our lists are cleared. We can go ahead and enter data now. Okay, so this is what we're going to do. We're going to go ahead and enter the data first. We're going to enter this data here. Okay, so I'm going to kind of minimize this, and that way I can see both screens at the same time. And what we're going to do is we're going to enter in the x values, which is going to be our L1 or our list 1. And so we see this is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that makes it. So at this point, we're going to enter in all our data. We start with 0. Alright, we go 0, enter. And then we put in so on. And we keep doing that. 50, and there's 60, 70, 80, 90, 100. Okay, and so we have here all our x values from 0 to 100 in tens, units of tens. So now we want to cursor over to the right, and then we go to our first block here, and we're going to enter in 64. Enter, and you want to check it as you go along. 65. And you want to check your entry here before you hit enter, because I almost didn't get that 5 in there. And then 67, check it, enter. 68, and enter. 70, enter. And so that's 40 and 70, so we're going right along. 71. Okay, so here we have 50 and 71, and now we go to 60 and 72. Enter. 70 and 73. Okay, so that now we put in 73 for hours. There's 70, 73, 80, and so we're going to put in 74 now. Enter. There's 80 and 74. Okay, now we want 75. And there's 90 and 75. And now we put in 76. And there's 176. Okay. Now we've got our data. Alright, so let's go back. Now what we want to do at this point is we want to find a line of best fit. And we're going to do that on the calculator. So instead of these calculations here, calculating by hand, we're going to come up with our model on the calculator. So what we're going to do is we're going to enter in second, and then stat plot, and then plot on, enter, select a graph type, and set window. So we go to second and stat plot up here in the Y. Okay, now we want, see this says plot 1 off, and we want it on. So we want to select plot on. So we click enter, and you see it's flashing on, but it's not selected on yet, so we select enter, and now it's highlighted for on. And now it says select graph type. Well, I like dot, I don't like it connected. This is not connected points. These here are connected points. This is a histogram here. We want just points that are not connected. These here are box and whisker. We don't want those. That's for different function. And then we have our X list. That's our L1. Our Y list. That's our L2. Mark. Okay, I like the little squares, but you could also use plus signs and dots. The squares tend to show up a little bit better. Okay, so that's our window. Okay, and now from there, we're going to go to Stat and Calc. And then, so we're going to go to Stat. There's Stat. And now we're going to go to Calc. And so we've selected Stat. Now we're going to go to Calc. So we've got to hit the right arrow for Calc. Okay, and now we're going to hit 4 for linear regression. There's linear regression, and there's the linear regression in slope-intercept form. They don't use M here, they use A times X, and the B, that's your Y-intercept. So you can either cursor down, or we can just select 4. is linear regression. Now we've got to select L1. So we go to second, and L1 is above the number 1 button. See, here's L1. Select that. Now we have to put this comma in here to separate the L1 and L2. So here's the comma button, which is above the 7. Select that. And now we have to select second and L2. Second and L2, and that's above the 2. And there we go. And now we hit enter. And there is our model, our linear regression model, our equation. So in other words, A is 0.12, and it goes on, right? So in other words, what this is saying is y equals 0.12 x plus 64.409 for our y-intercept. Okay, what we want now is we want this in our equation, in our scatter plot. So what we do is we go to y, and we're going to clear this equation right here. And what we're going to do is we're going to go to var, which is vars is right here above the tangent near the clear button. We're going to select vars, and then we're going to select 5 for statistics. So we're going to select 5, and now we're going to go to EQ. And we right arrow one more time to EQ, and now regression equation, and now we hit enter. And there it is. The equation, we don't have to type that equation in for y, it's there through this vars 5 stat EQ and enter. Okay, now if we go to graph, see here's our x and our y axis, we don't see anything. So what you want to do is you want to go, since our data is going from x is 0 to 100, you want to go to window. Okay, and we want to go x from 0 to 100. So we're going to go a little bit more. If we put 100, we're going to cut off one of the points. I'll show you. If we put in 100. And then the y's, they go from 64 to 76. So the y's, y-min, we'll put that at 0, and y-max, we'll put that also at 100. And let's see what that looks like. There's our points, and there's our linear regression. There's our line. That is this line right, the equation of this line right here. Okay, 0.12x plus 64.4 as a slope-intercept form equation. Now you see the last point kind of gets cut off a little bit, so that's why at window for x max might be better to go to 120. And see, now that point's not cut off anymore, so it's better to go a little bit further out. And that's what that looks like on a scatter plot with your line of best fit or your linear regression line superimposed on your scatter plot. Okay. And so here we have find the line of best fit. That's what this is here. Graph the line of best fit on a scatter diagram. That's what we did that. Okay. So instead of putting, instead of typing in 0.1209 x plus 64.409 into, you could have typed it in here. See if you'd have done it like this, 0.1209 1, 2. So let's say we clear this. And we put in point 1, 2, x plus 64. And let's see. Oh, we forgot the x. All right, we need the x in there. The keyboard, I got to put it in there. There we go. And there it is. So you could have either manually typed it in, or you could have used the vars 5-stat equation, enter in that. But in order for this to work, you've got to do this first. In other words, if you do this and then you do something else, and then you do the vars 5-stat eq, it won't work. Once you enter your data, then you put the stat calc for linear regression second, comma, second L2, enter. Then you got to go straight into doing the vars 5-stat eq and enter. If you do something else in between these two, it won't work, or at least I haven't had it work. So it works best if you do those together, like it was all one line, one stream of using the calculator. Okay, well, I hope this, let's see if there's anything else here. Interpret the slope. Okay, so the slope is 0.12. Okay, or they use 0.1209, which means the apparent temperature rises 0.1209 degrees for every 1% increase in relative humidity. Using line of best fit to predict the apparent temperature when actual temperature is 72 degrees Fahrenheit and relative humidity is 45. And if you plug that in 45 for your, because remember now 45, the x values is your humidity, so you have to use 45% relative humidity in for x in your equation, and we get 69.8 degrees Fahrenheit. Well, the actual was 72, so that's pretty close. Not exact. You see these there's points above and below the line. They're not exact, but they're pretty close. So it's a fairly good model. Okay, I hope this helps you with working through lesson 5 and linear